far as a way for us to represent and show the derivative. So basically what they're asking is, here's a chart. All right, here's your values of x. Here's the value of f of x at those values. Right? So you could say these are like your input. These are the output values. And then these are the output values for the first derivative. So what they're asking us to do is find the first derivative at the value of x. In this example, we're going to find the value at x equals 1. OK? So therefore, we need to find the first derivative. You guys can see that this is a product. So therefore, we need to use the product rule. So to find the product rule or the derivative, this expression, I'll do dy dx equals 1 over 2 square root of x, which is the derivative of my square root of x, times f of x plus f prime of x times the square root of x. So that is basically finding the derivative of this expression here using my product rule. And therefore, now I need to find it at the value of x equals 1. So for this function, I can just plug in 1. For f of x, when f of x equals 1, you can see that it's negative 3. And at f prime, when x equals 1, that's going to be 1/5. And then I can just plug a 1 in for that x right there. So therefore, in mathematical notation, I can write dy dx such that x is equal to 1. That's what that line, such that x equals 1. I can do 1 over 2 times the square root of 1 times f of x at 1 is negative 3. Plus f prime at 1 is 1/5 times the square root of 1. And therefore, now we can just simplify our results. And dy over dx such that x equals 1. So therefore, this is going to be a negative 3 over 2 plus 1/5. OK? And I'm just going to less. Yes?
Isn't the chart already the derivative at first derivative at x equals 1 is 1/5?
Yes. That's why I wrote in 1/5 and for the first derivative f of x.
So 1/5.
No. That's the. So we're doing that expression, basically that.